what are some, this is a good time, what are some questions you guys need to ask? Are these tools helpful to you? Are there tools that maybe you would like to learn about?
More of like a practical question.
Sure.
So everything you did was great. It was really clear, and all the steps, but I just can't imagine in the future if I'm like, I need to look at some alpine trails. Like if I'm going to remember how to do this, have you got this down just from like doing it constantly and like knowing kind of the right path to take to kind of look at specific data or specific analysis?
Yes. So when you're looking at vector data, there are not that many tools, different geoprocessing tools you need to use. So it really just comes down to knowing what tool will work for what you, to answer the question you want to ask.
Cool.
Buffering and intersecting will get you, 75. Those are probably the two most common tools used. Yeah, then there's, you can get into the more complex tools like spatial join, which we're not going to cover right now because that is more of a complex tool. But yeah, you can see in my, where'd my mouse go? In my geoprocessing tab, in my favorites, these are literally the tools I use the most.
Okay, cool. Thank you.
Hey, Josh, hop back to the slides because there are a couple of examples of like kind of general questions that maybe will spark some people's curiosity.
Right.
So this slide and the slide before both have a couple of, I don't know if they're things that you guys do, but they're kind of general and can be translated to what you might be doing. I know in the survey, some of you talked about working with conservation easements. So maybe you're trying to figure out what are all the different types of objects and entities within a conservation easement. Maybe you get a stream layer and you only want what's in that easement, or you want to know where a road or a trail crosses in and then back out of an easement. So that would be like your tundra example. So looking at these, and maybe the slide before too, are there things that you might need to do with your own data that you want to know how you would do them maybe? It's okay, it's early. You'll get ideas.
Right.
As you do more, you'll be sparked. But yeah, just to answer, I guess Tyler's question, it's just experience, and as Josh said, there's a lot fewer tools for vector data than raster data. So you can just like look at the toolbox and look at the 20 tools, and then figure out which one might be the right one. But kind of like playing guitar, like they say that most songs are played with like 3 guitar chords. Most spatial analysis can be done with select, buffer, and intersect. They're your catch-all.
Yep.
I thought of a question for data that I was working with recently. I was looking at camera trap locations where we were studying wildlife with the images, and we wanted to know the land cover type or like habitat classification of each camera trap location. Would that be like similar? I don't know. I was thinking it would be similar to the land cover type crossing trail segments, but I don't know if it would be intersect because it's not a continuous trail. They're independent locations.
So you could either pull from wherever that point is specifically, or you could make, say, a buffer around each camera point to get the local vegetation, and then intersect. So you would have the different types of vegetation within a certain area of each camera point.
Okay.
You could do the intersect on the point layer without buffering as well.
You could, but
Yeah.
that and that would give you just the vegetation
Right. It would give you the vegetation that the point layer is actually
of the
on,
point.
or you
Right.
could buffer and kind of get the feel for what's in the area, or spatial join could do that too. So there would be a few ways to actually do that one.
Okay, thank you.
Mm-hmm. All right. Any other curiosities with your own data? Okay. So we can move on to some more complex analysis. So if we want to find a backcountry campsites or places to put new backcountry campsites, we could ask multiple questions of our data to come up with an answer. And with that, we'll play with some raster analysis. So again, the difference between vector and raster. Vector, which is what we've been working with so far, points, lines, and polygons. This is discrete data. So what we mean by discrete data is that if I click anywhere, if I'm looking for, say, a stream, if I click on a stream, that line is a stream. If I click anywhere else that is not a stream, it is not a stream. So it's just a simple yes or no. Does something exist here or does it not? Whereas with raster data, which we will add, so if we go back to our catalog pane on the right, I'm going to add our DEM, our digital elevation model, which is a raster. So if I look at a DEM, which is raster, you can see that it is covering a large area of the Earth, or a small area of the Earth, respectively. And as a raster, wherever I click in this, I'll show my pop-up here. Well, that's a big pop-up. Wherever I click, that raster exists and it has a different value. So at this point, it is 2,402 meters above sea level. And at this point, it's 3,915 meters above sea level. So it is continuous data, not discrete. So it covers, again, I used the analogy before, it's like a blanket covering the surface of the Earth or any surface. And there are a lot of tools open to rasters, many more than vector. So if we want to find places that are 200 feet from water, 100 feet from a trail, and on flat ground, what would we need to find? Let's look at the vectors first. The tools we would want would be buffer, right? Because we want to buffer 200 feet from water, and we already did that with our streams. So we can run that same buffer. So if we go to geoprocessing, so analysis, tools, in our geoprocessing pane, select buffer once again. We're going to buffer our lakes. Oh boy, but we haven't, we need to clean up our lakes first. We've got these water bodies here. But again, we're not as concerned about the swamps and marshes. We just want to stay away from the lakes and reservoirs. Can anyone tell me how we would look only at lakes and reservoirs in our analysis?
Would you do the definition query again?
Yes, we would. We would do a definition query. So on our NHD water bodies, we will right click in our table of contents, select properties. That already is on our definition query tab there. We will make a new definition query where our F type includes the values, right? So the F type is the attribute we want to go by. We want to include multiple values. Oh boy, and let's bring up that list. We want 390 and 436. That is a lake. That is a reservoir. And we will hit apply. And OK. So now only our lakes and reservoirs show up. Now I'm going to add one more step in here. You can see we've got a lot of lakes and reservoirs that are outside of the national park. So if I only want to analyze those that are if I only want to analyze those that are inside of the park, and I want to ignore these that are outside, and go to my map, and I can select by location. And I'm selecting my water bodies, NHD water bodies, that intersect. I want my boundary. Right? So water bodies here, intersect relationship, the selecting features, so the things that will govern where the selection happens is the boundary. So I'm looking for things that intersect that boundary. It will make a new selection, and I will click OK. And you'll see now it does not select any of these out here, all of these little water bodies. So now if I were to run an analysis on this layer, it would only analyze those things that are selected, which is exactly what we want. As this is also water, and we want things that are 200 meters away from water, we will, in our Analysis tab, Tools, Buffer. Our input features are going to be our NHD water bodies. Our output, we can say, lakes buffer. And you don't have to name it that. I just think that's a decent name. And we are going to, once again, buffer at 200 feet. Planar. We're not going to dissolve this because we're not going to have a whole lot of, we will have some overlap. So we will dissolve it. And once your window looks like this, so NHD water bodies, name your output feature class. You want a distance of 200 feet. We want to dissolve. You can click run. Now, on our map, I will clear my selection. Lakes buffer. If we zoom in, we can see now that our lakes have a buffer as well. I'm going to once more zoom to my boundary. Okay, so we've got 200-foot buffers from our water. Now let's say we also want, as our question says, 200 feet from water, 100 feet from a trail. So we will buffer once again, analysis, tools, buffer. What would my input features be? Right, it would be my trails. I'm going to name this trail buffer. And you'll notice when I name things, I always use underscores and not spaces. Esri products definitely do not like spaces, so we avoid them at all costs. This distance is going to be 100 feet. And we are going to dissolve once again. And run. Now we've got a buffer on our trails. Again, if we zoom in, we can see that. All right. Next, we want it to be on flat ground. So for this, we're going to use our DEM. We're going to do some raster analysis now. So again, from our analysis page or tab here at the top, we'll pick tools. This time, we are going to find areas that have a very low slope. So we're going to search for the slope tool. And you'll see here it says slope 3D analyst or slope spatial analyst. We're going to use the spatial analyst. It's the same tool. So what this tool does is it looks at each adjoining grid cell in a digital elevation model. You can see if we zoom in, well, let's get something that's a little more change, well, or not. This is a very, I believe I got 1 meter, a 1 meter dem for this. So it looks at each pixel, each adjoining pixel, and it finds the difference in those elevations. And based on that, it creates a slope value. So a high slope value would be a high difference in those two elevations, which would be a steep slope, whereas a small difference in values would be a very shallow slope or flat ground, which is what we're looking for. So our input raster is going to be the only raster we have. Oh.
Can you show them how to enable?
Yes. Okay. Yep. So if you need that license, you can click on project here. So again, top left, project, licensing. You'll have a list of all of these, licensed, licensed, licensed. Oh, we don't have business analyst. Oh, hey, ArcGIS Online. That should be all good.
You have a named user license, so you can't do it. They're on remote desktop, so they have to.
Oh boy.
Yeah. So go where Josh is. So project tab.
Project licensing.
Yep. And then
And you
click
want
that button.
Manage your data
Configure.
licensing.
No, not manage. It's configure.
Oh, it is.
Yeah. So
thought I
you
was-
guys who are on remote desktop, you will click this button, configure your licensing options. And when you click it, it will look very different. When you click it, you'll get a list of all the different extensions. They're like plugins or like added functionality. You'll get a list of all the ones available to you. And what you want to do is check the box for Spatial Analyst. And that's it. So you'll check the box, hit OK, and then go back, and then it'll let you open that tool. So Josh is logged in differently than you guys are on remote desktop. The licensing is different, so the steps are different. And then who was it that was on ArcMap? I'll send you the steps in the chat. That was Miranda. Okay. All right. So I will send Miranda how to do it on ArcMap. Okay.
All right. Okay, great. So now, when we say, now we can click slope, and it should bring up your slope tool. And once again, our input raster from the dropdown is the only raster we have in our map. So it's that DEM 2017. Output raster would just say slope. And we'll keep it with degrees. Yeah. And we will click run. Whoa. And we'll get something like that. You can see these light areas are areas of low slope, of less than 1.72 degrees. And these darker areas are a steeper slope. You just did your first raster processing. Congratulations. Now, we only want areas with less than a 10-degree slope. So to do that, we're going to do more raster analysis. We're going to use something called Reclassify. So once again, in our Analysis tab, in our Tools, we will look up Reclassify in our Spatial Analyst. And our input raster is going to be our slope. The field is the only field we have, which is value. Now, I know, oh boy, I clicked a button.
I'm not on mute.
Number of classes. We only want 2 classes. We want a yes class and a no class. Cannot create. Oh, remove all remap records. Classify. 2. Cannot. Okay, we'll start our own. So we want things that go from 0 to 10. So the start value is 0, the end value is 10, and we are going to change all of those to a 1. And then things that go from 10 to 90, we want to be 0. So what this is telling it is that anything that is 10 degrees or less will be a 1, and anything that is higher than 10 degrees will be a 0 or no. So we want yes and no. Our output raster will be slope reclass. And execute. Excellent. You should have something that looks kind of like this. Now, who's confused? Excellent. That's what I want to hear. I'm so happy. We've got one more step before we can run our final analysis. So right now, we've got data that is vector and data that is raster. Those two data storage models have a hard time interacting smoothly. So to run analysis tools cohesively, we need to either turn all of our vector data into raster or all of our raster data into vector. In this instance, we will probably want to turn our raster, because there's just one, into vector data. So to do that, we'll use a tool called Raster to Polygon. So in our Analysis tab in the top, we will select Tools. And in that text box, we'll type in Raster to Polygon. Convert a raster data set to Polygon features and select. And our input raster is going to be slope reclass. Our field is going to say value. And our output poly is going to be slope polygon. Everything else should be the same. So when it looks like that, you've got your slope reclass as your input raster, field value is value, and output polygon features are named. Now you can click run. Excellent. So now we don't need our slope raster or our DEM. And now we only want to look at things where our slope reclass value, our new polygons that we made, we only want to look at where those are. Where's our slope reclass polygon? Oh, up at the top here. We only want to look at those that are a 1. So once again, we'll right click on our slope polygon in our table of contents. Select properties, definition query, and we want where grid code is equal to 1. Click apply, click OK. Oh, we're going to turn off that slope reclass as well. And you can see these pink areas are now areas that are flat. All right, we have now done all of the setup. So we get to answer our question now. Once again, our question is finding areas that are 200 feet from water, 100 feet from a trail, in the forest, and on flat ground. So the first step is going to be finding those areas that are on flat ground and in the forest. If we're comparing two polygon layers, what tool should we be using? To overlay those polygon layers. Right. Intersect. So again, analysis, tools, intersect. Do we have only our forest? Oh, we're only going to be looking at the Bear Lake area because that is the land cover data that we have. So our input features are going to be our, oh, and look at that. We still have stuff that is not forest. So we need to set a definition query for forest. So Bear Lake NLCD, properties, definition query, vegetation is equal to forest, apply, okay. Now we've only got our forest. So when we input, we've got our Bear Lake NLCD polygon and our slope polygon. We're going to intersect these two things. Same as input, because it's a polygon, and we'll click output feature class. This will be flat forest. And click run. So now we've got, if I turn off my NLCD data and my slope data, we've got these green sections here that are flat and in the forest. So the things we don't want are, we don't want to be near water and we don't want to be near a trail. This is where the erase tool comes in. So we'll do analysis, tools, and in our text box, we'll type in erase. You can see that, analysis tool. Our input feature, this is what we are going to erase from. So our input feature is going to be flat forest. And the erase features are going to be our lakes buffer. We'll start, and we're going to run this tool 3 times, right? Once for lakes, once for streams, and once for trails. And we'll name this flat forest no lake. Save. And we will click run. And we will get a layer that does not contain anything near lakes. So once again, we will run the erase tool. So analysis, tools, erase. Our input feature this time is going to be flat forest, no lake. Our erase features will be our stream buffer. Where did it go? Streams clipped buffer. And we will call this flat forest, no water. Because now we're getting rid of streams as well as the lakes. So when we click run, we are left with areas outside of the stream buffers. And we will run this one more time. So with erase, we can stay in this geoprocessing window, and the input features will now be flat forest, no water, and the erase features will be our trail buffer. And we'll name this camp spots. Because this is the final layer that includes everything that we want. It answers all of our questions, right? It is 200 feet away from lakes and streams. It is 100 feet away from trails. It is in the forest, and it is on flat ground. And if you look in our table of contents, it has added all of these, but we no longer need them. So we can right click and remove flat forest, no water, flat forest, oh, I didn't want the attribute table, flat forest, no lake, flat forest, slope polygon, trail buffer, lakes buffer, streams clipped buffer. And what we are left with are the areas, and we're going to make these bright pink. So if we click on the symbol in the table of contents on the left, it brings up our symbology tab. I want them to be bright pink. What we're left with are areas that fit our criteria. So this is the basic workflow you will use to do any sort of analysis in ARC.